Hello, everyone. Hello again, everyone, I should say. Um, there are some additional topics with regard to algebra that we need to cover. Chapter 7, sections 7.3 and 7.4 talk about ratio, proportion, and variation, and also linear inequalities. Now, last time we had spoken about linear equalities, and we'll see that there are some similarities as well as differences here between linear equalities and linear inequalities. This section will have, or these two sections will have a lot of examples to illustrate the topics at hand. Please look at the examples in the book to further illustrate the concepts. And email me if you have any questions. The first topic is about ratios. A ratio is simply a quotient of two quantities. Remember what a quotient is: when you have one integer divided by another integer. And it can be written a couple of different ways. It can be written a ratio of A to B, a fraction A over B, or with a colon, A colon B. And so when you compare the two numbers in the same way, you have to, in this way, you have to make sure that the units are the same. So if you're comparing times, for instance, you want to make sure that both A and B are in hours, minutes, or seconds, respectively. And if they're not, you want to make sure that you convert to the proper units before you perform the comparison of ratio. So if you turn to page 313, let's look at some examples about this. If you look at number 13, for instance, or excuse me, number 3, for instance, determining the ratio and writing it in the lowest terms. They say $17 to $68. This is a ratio, 17 to 68. And if you get your, if you look at the number of times 17 goes into 68, you'll see that it goes in 4 times. So the ratio here is 1 over 4. So the lowest terms here for this ratio is 1 over 4. Now, number 6 is an illustration of what happens if you have two different units. You want to make sure that your units are the same. 60 inches to 2 yards. Now, we know that a yard is 36 inches. So 2 yards would be 72 inches. So if 2 yards are 72 inches, 60 inches to 2 yards, would give us 12 goes into 65 times, and 12 goes into 72 6 times. So the lowest ratio, or the lowest terms of this ratio, are 5 to 6. Similarly, look at number 7. You have 5 days to 40 hours. Five days to 40 hours. A day is 24 hours. So we're looking at 5 times 24 is 120. 120 hours. To 40 hours. And we can see that 40 goes into 123 times. So the ratio here is 3 to 1. Similarly, in number 8, 75 minutes. 75 minutes to 4 hours. 4 hours is 60 minutes in an hour. So 100 or 240 minutes. So 75 minutes to 240 minutes. 75 to 240. And $75 is divisible by 15, and 240 is also divisible by 15. So this gives us 15 times 5 divided by 15 times 16. And we know that any number divided by itself is 1. So what we're left with is a ratio of 5/16. So these are some examples of ratios, and try some of the other exercises in that section to illustrate illustrate further. A proportion is kind of like a quotient in that we're talking about an equation that determines whether two ratios are equal. So if we have a fraction like this, 3/4 equals 6/8, we can see if a cross product exists. So if A divided by B equals C divided by D, then the cross products AD and BC are equal. So we can look at this and we can say, oh, okay, 3/4 is the same as 6/8. 6/8 is the same as 3 times 2 divided by 4 times 2, and the 2's divided by themselves equal 1. So you'd be left with that. So a cross product is something that we will explore here with these examples here on page 314. So if you look at page 314, we're supposed to decide whether each proportion is true or false. So we're looking at 5/35 equals 8/56. So how do we determine whether or not this is equivalent? So a cross product would take the numerator of this fraction and multiply it by the denominator of this fraction. So 5 times 56, where we're looking to see if 5 times 56 is the same as 8 times 35. So 5 times 56 is 280. And 8 times 35 is also 280. So this is a true statement. Now if we look at number 15 and we say, okay, 120 over 82, is this the same as 7/10? Now, just looking at these, we can see that 120 over 82, when the numerator is larger than the denominator, this fraction will be a number greater than 1. But in this case, it's not greater than 1, so we can automatically say that this statement is false. But let's just do the cross product to see what happens anyway. So 120 times 10, we're checking to see whether that is equal to 82 times 7. So 120 times 10 is 1200, and 82 times 7 is 574. So the cross products do not add up, and this statement is false. So these are examples of some proportions here. So what we want to do next is take a look at an equation that has an unknown. So jump down to number 20. Here's an example. 49/56 equals x over 8. Now, if this statement is true, and it's not asking us if it's true or false, it's asking us to solve the equation. When the problem says solve the equation, they're referring to this unknown x. So let's perform the cross multiplication. 8 times 49 equals 56 times x. So 8 times 49 is 392. 392 equals 56x. We use the multiplication property of equality, divide both sides by the same number. Remember, any number divided by itself is 1, so what you're left with is x equals 392 divided by 56, which gives us 7 equals x. So the solution set to this problem, or the solution to this problem, is x equals 7. Sometimes the fractions are not so easy. If you jump down to number 23, let's solve this problem. 3x plus 1 divided by 7 equals 2x minus 3 divided by 6. Now this is an equation, so we can perform the cross product and see what happens. So 6 times 3x plus 1 equals 7 times 2x minus 3. We use the distributive property. 6 times 3x is 18x, plus 6 times 1 is 6. 7 times 2x is 14x. 7 times negative 3 is negative 21. So let's use the addition property of equality here. Let's subtract 6 from both sides. As long as you use the same math for both sides, it does not fundamentally change the equation, remember. So negative 21 minus 6 is negative 27. Now let's remove 14x from both sides, and this gives us 4x equals, again, 14x minus 14x is 0, so 4x equals negative 27. So we divide both sides by 4, and x equals negative 27 over 4. Wow, remember what we have to do. We have to go back into the original equation and see if negative 27 fourths is the true answer. So let's go back to let's go back up to here, and let's say, okay, 3 times x, where x is negative 27 fourths, plus 1 over 7 equals 2 times negative 27 fourths minus 3 divided by 6. Okay. So 3, negative 27, 27, this gives us negative 20 1/4 plus 1 over 7 equals negative 13.5 minus 3 over 6. Negative, let me see, negative 19 1/4 over 7. Going to run out of room here. Equals negative 16.5 divided by 6. So negative 16.5 divided by 6 is negative 2.75. And 19 1/4, negative 19 1/4 divided by 7 is also equal to negative 2.75. So negative 2.75, negative 2 3/4 equals negative 2 3/4. This is validated. So this solution, where x equals negative 27/4, is the answer that we're looking for here. Now, if we're thinking about some of these proportion and variation type problems, let's consider a word problem like number 25. No, let's get 26. In number 26, we have the price of ringtones. Now, most ringtones nowadays are free, but you can still pay for ringtones sometimes. But let's say if 12 ringtones cost $30, how much do 8 ringtones cost? This is a ratio problem. So if x equals the cost of 8 ringtones, then we can say, okay, $30 will give you 12 ringtones. We'll abbreviate that as RT. $30 gives you 12 ringtones. And X will give you 8 ringtones. So we have a ratio problem here. So this is 30 times 8 equals 12 times X. Okay, 30 times 8 is 240 equals 12x. Divide both sides by 12. Any number divided by itself is 1, so these go away. So 240 divided by 12 gives you 20. So it would cost $20 for 8 ringtones if 12 ringtones cost 30. So this is a ratio problem that you might run into from time to time. Similarly, let's jump down to number 30. This is the price of shirts. So the problem says if 7 shirts cost $87.50, find the cost of 11 shirts. So let's let X equal the cost of 11 shirts. This is the unknown. We don't know what the cost of 11 schertzes. So X divided by 11 schertz, so X dollars divided by 11 schertz, equals 87.50 divided by 7 schertz. So X times 7, or 7X, equals 11 times 87.50. So 7X equals 11 times 87.50 is 962.50. Divide both sides by 7. Remember, this is the multiplication property of equality. Basically, you're multiplying both sides by the same number, 1 over 7. And then you solve for X, and X equals 137.50. You jump down to number 38. The distance between cities on a world globe, the distance between Rio de Janeiro and Hong Kong, two cities that are actually 17,615 kilometers apart, is 21.5 inches. The actual distance between Paris and Stockholm is 1,605 kilometers. How far apart are Paris and Stockholm on this globe? Now, obviously, we can't put them all into kilometers or into inches, because one or the other will be dramatically different value. But let's look at the ratio here. So let's let X equal the distance apart on the globe. Distance apart on the globe between Paris and Stockholm. So we know, and we're given 17,615 kilometers between Rio de Janeiro and Hong Kong, but that's only 12.4 inches on the globe, equals 1,610 actual kilometers between Paris and Stockholm, but we don't know how many inches this is. So we can perform a cross multiplication here. So 1610 times 12.4. Now let's put the units here. So 12.4 inches and 1610 kilometers equals 17,615 kilometers times X inches. Okay. Now, 1610 times 12.4 is 19,964. But we are multiplying kilometers times inches, so the units will be kilometer inches. This equals 17,615. 17. Let me cross this out. Sorry about that. 17,615 kilometer inches. It's a 7. But what we need to do is we need to divide both sides by 17,615 kilometers. Now, kilometer part will cancel out. 17,615 cancels out because any number divided by itself is 1. Kilometers cancel out over here, and what you're left with is inches. So 19,964 divided by 17,615 gives us I think I didn't do this right. 1610 times 12.4. No, I'm sorry, it's not 1610. The problem states 1605. So I'm sorry about that. 1605. And it's not 12.4 inches, it's 21.4 inches. What am I looking at? 21.5 inches. Oh, I'm looking at problem number 37. I'm sorry. Let's go. Let me just rewrite this. So what we have here in problem 38, problem 38, not 37, 17,615 kilometers is 21.5 inches equals 1605 kilometers over x inches. Okay, sorry about that. So what we have here is 17,615 kilometers times x inches equals 1605 kilometers times 21.5 inches. So what we get here is 34,507.5, and the units are multiplied together. And then we have 17,615 kilometers times x inches. So if we divide both sides here by the 17,615 kilometers, the number divided by itself is 1. Kilometers cancel out as well, and kilometers cancel out over here. So all you're left with is inches in your solution. So x equals 2 inches. So, sorry about that confusion. The actual distance on the globe between Paris and Stockholm is 2 inches. There are a lot of other examples and exercises in that section. The next topic that we want to talk about is direct variation. Now, direct variation is takes the form of this statement. If a number, we'll call them y and x, if y varies directly as x, or y is directly proportional to x, that would be the case if there exists a non-zero constant that we'll call k, such that y equals k times x, or y divided by x equals k. So if you look at example 6 on page 310, this illustrates this, this factor. And suppose y varies directly as x. Suppose y varies directly as x and y equals 50 when x equals 20. So if it varies directly, we know that from the PowerPoint slide, we know that if y varies directly as x, there's going to be some non-zero constant k that such that this equation, y equals k times x, is true. So since we know what y is, we replace y with the 50. We replace the x with 20. And then we can solve for k, dividing both sides by 20. K equals 5/2. Now, if we know that this is the case, y varies directly as x, and y is 50 when x is 20, and we know the constant, once we solve the constant, with the same direct variation, we can plug in any value of x and find the corresponding value of y. And they've done that in this example. They tell you to find y when x equals 14. If the formula becomes y equals 5/2 times x, and you're asked to find y when x is 14, you simply plug in the value 14 for x to solve for y. So 5 times 14 divided by 2 is 35. So let's look at some of the problems at the end of this section. Problem number 63. These are, again, direct variation problems. Direct variation. In other words, y varies directly as x. So here we say if x, number 63, if x varies directly as y and x equals 27 when y equals 6, find x. Now, they say x varies directly as y, and x equals 27 when y equals 6. So if x varies directly as y, the equation is going to say x equals k times y, not y equals k times x. So if x is 27, we plug that in here, 27 equals k times y, which is 6. We solve for k by dividing both sides by 6. Any number divided by itself is 1. 27 divided by 6 is k. So k equals 27/6. The problem says if this varies, find x when y equals 2. So x equals blank when y equals 2. So what we do here is we just plug in this value of y into the equation. Now we know what k is. This is x equals 27/6 times y. So now we plug this value of y into this equation here. X equals 27/6 times 2. So x equals 27 times 2 divided by 6, or 9. Similarly, in number 64, if z varies directly as x and z equals 30 when x equals 8, find z when x equals 4. So z varies directly as x. So this is telling us z equals k times x. If z is 30, when x is 8, we solve for k. So any number divided by itself. What we're left with is k equals 30 over 8. So our formula becomes z equals 30 over 8 times x. Now we're supposed to find z when x equals 4. So we take this value of 4 and plug it into this variable here. So z equals 30 divided by 8 times 4, or 30 times 4 divided by 8, which gives us um, which gives us 15. Now we note that k is not in its lowest form here, so this could actually be, since both the numerator and denominator are divisible by 2, we could have 15 over 4x. So z could also be written z equals 15 over 4x. So these are some examples of direct variation. Now, in a word type problem, that would be to solve a variation problem, you have to read the problem very carefully, of course, write the equation, the variation equation, substitute the initial values and solve for the k. The important thing is that you need to find the constant, and then rewrite it with the value of k from the solution for k, and then substitute the remaining values, solving for the unknown, and find the required answer, just like these last examples were all about. Another form of variation, instead of direct variation, is variation as a power. So this would come out in the term y varies directly as the nth power of x if there exists a non-zero number k such that y equals k times x to the nth power. Let's look at page 316 for some illustration of these. So number 65 says if m varies directly as p squared and m equals 20 when p equals 2, find m when p equals 5. This is number 65. So what this is telling us is m varies. So m varies directly as p squared. So k times p squared. And m equals 20 when p equals 2. There's still a constant k in there. P equals 2. P equals 2 squared. So 20 equals k times 4. Solve for k here. K equals 5. Then to find m when p equals 5. So then this is saying that our direct variation problem here is m equals 5 times p squared. So to find m when p equals 5 is saying 5 times 5 squared, which is 5 times 25, or 125. So if m varies directly as p squared and m equals 20 when p equals 2, find m when p equals 5. Similarly, in number 66, if A varies directly as B, sorry about that, as B squared, and A equals 48 when B equals 4, find A when B equals 7. So here's the formula. A equals K times B squared. Then we plug into the equation 48 equals K times 4 squared, which is 16. So 48 equals 16 times K. Find out what K is by dividing both sides by 16. So K equals 3. Remember, we divide both sides by 16 so that we isolate the variable by itself. And if you divide both sides by the same number, you haven't changed the solution set. So 48 divided by 16 is 3. So our equation is A times 3B squared. So find A when B equals 7. So A equals 3 times 7 squared. So A equals 3 times 7 squared is 49. 3 times 49 is 147. There's also, with relation to variation, there's also inverse variation. Y varies inversely as x if there exists a non-zero real number k, such that y equals k divided by x, or equivalently, x times y equals k. You can also say that y would vary inversely as the nth power of x if there exists a non-zero real number k, such that y equals k divided by x to the nth power. So here's some other examples of that. Number 67, if P varies inversely as Q squared and P equals 4 when Q equals 1/2, find P when Q equals 3/2. Again, this is number 67. So what this is saying is P varies inversely as Q squared. So P equals K, and inversely means that it's divided by. Okay, so P equals K divided by Q squared. So if P equals 4 when Q equals 1/2, this is the same as saying 4 equals K divided by 1/4. If you divide by a fraction, remember this is the same thing as multiplying by its inverse. 4/1 times K. So what this is saying is 4 equals 4K. Divide both sides by 4. K equals 1. If K equals 1, then P varies inversely as Q squared. So if Q is 3/2, then 1/3 3 over 2 squared is the same as saying 1 over 9/4, which is the same as saying 4 over 9. Okay. Jump down to number 71. Over a specified distance, rate varies inversely with time. If a car goes a certain distance in 1/2 hour at 30 miles per hour, what rate is needed to go the same distance in 3/4 of an hour? So remember, our distance equals rate times time. So let's let r equal rate and t equal time. Now, the problem says that over a specified distance, rate varies inversely with time. So here's an inverse variation problem. Rate varies inversely with time. Inversely just means that the one variable is in the denominator. And at a rate of 30 miles an hour, time is 1/2 an hour, 30 minutes. So it's 1/2 an hour. Then 30 equals, if you divide a variable by a fraction, it's the same as multiplying by the inverse of the fraction. K times 2 over 1, or 2. So K equals 15. So our rate equation, our inverse rate equation, becomes 15 divided by t. The problem now states what rate is needed to go the same distance in 3/4 of an hour. So rate is, the constant is k, and the time is 3/4 of an hour, which is the same as multiplying. 15 divided by 3/4 is the same as 3/4 is the same as saying 15 times 4/3. And this gives us 20 miles per hour. So you have to carefully read the problem, and you have to write down what it is asking you. In this example, in the last example, it was an inverse problem, but in this one, it's just just a direct inverse with no power involved. In section 7.4, we start talking about linear inequalities. Now, we had talked about linear equalities before, but linear inequalities are a little bit different, because when we're talking about an inequality, we would have, instead of an equal sign, we would have a greater than, or less than, or greater than or equal to, or less than or equal to symbol. So a linear inequality would have a variable x. So ax plus b is less than c, for example, is one indication or one example of a variable. And you remember the addition property of equality. The same thing occurs here. So if two variables, let's call them a and b, If A is less than B, then A plus C is less than B plus C. So if C is added, the same value is added to each side of an inequality, just like in an equality or an equation, it doesn't change the solution. So let's look at some examples on page 326. Page 326, number 9, 4x plus 1 is greater than or equal to 21. So what we want to do is we want to put like variables on one side. So we have 4x is greater than or equal to 21 minus 1, or 20. Divide both sides by 4. X is greater than or equal to 5. Now in interval notation, this would be written with a solid bracket to the left, 5 and infinity to the right. Or in graph notation, zero, 1, 2, 3, 4, 5 with a bracket and then an arrow going all the way to the right. Now we're not going to talk a whole lot about these types of notations in class, but the book goes into great detail about them. So the bracket, I'm sorry, this should be written like this, not a solid bracket, but a rounded bracket, not a square bracket, but a rounded bracket. What this means, the brackets actually have a connotation here. A square bracket would indicate that the value of 5 is one of the solutions in this set. So it can go down to 5. And the rounded parenthesis, the rounded bracket, just basically means that it can go that far and doesn't end. Obviously, infinity doesn't end. Now, if you jump down to number 14, you'll see an illustration here of a solution gives us negative 2x is greater than 10. Negative 2x is greater than 10. Now, one of the things in this type of inequality is, let's jump to the next slide here to show you this. The multiplication property of equality is very similar to inequality, that is very similar to the multiplication property of equality. So, however, if you divide by a negative number, then we must reverse the direction of the inequality symbol. So if C is positive, then A is less than B, and A times C is less than B times C. These are the same solutions. But if C is negative, A is less than B, and A times C flips that over, so it's now greater than B times C. It's the same solution. We must reverse the direction of the inequality symbol. So getting back to this problem, negative 2x is greater than 10. If we divide both sides by negative 2, any number divided by itself is 1. we must flip the the direction here. So 10 divided by -2 is -5. Now in interval notation, this would be written negative infinity to -5, and a rounded bracket. The rounded bracket means it's less than, not less than or equal to. If it were equal to, then it would be a square bracket. So our graph notation for this would be like this: 0, -1, -2, -3, -4, -5. So there's a rounded bracket here. And everything to the left of this rounded bracket. So everything negative from that. So the problem states, give the solution set in both interval and graph forms. This gives us the interval form and the graph form. And again, if you're curious about the specifics of what the different graphs mean, please very carefully look at the text. When we solve linear inequalities, again, we have to simplify each side separately, isolating variable terms on one side, just like in equalities, and then solving for or isolating the variable. And if you have to divide by or multiply by a negative number, the direction of the inequality symbol must be reversed. That only happens if you multiply or divide by a negative number. So here's a few more examples that you can look at. Let's explore these. If you turn to number 57 on page 327, we have a illustration of a taxi cab fare. In a city, taxi cabs charge $3 for the first 1/5 of a mile and 50 cents for each additional 1/5 mile. Frank Steed has only $7.50. What's the maximum distance he can travel, not including a tip for the cabbie? So this is an inequality because it's going to be less than or equal to some value. So in this problem, let's let D equal the number of additional fifth of a mile. So 1/5 miles. Frank, let's look at Frank must pay $3 plus 50 cents for each additional 1/5 mile. And this amount cannot exceed $7.50. So we have an inequality. So what does he have? He must pay $3 plus 50 cents for each additional fifth of a mile. So each additional fifth of a mile would be D. This must be less than or equal to $7.50. So let's isolate the variable. So we'll subtract 3 from both sides, $3. And we're left with 0.50. D is less than or equal to 450. Solving for D, and it is a positive number, 0.50. What this is telling us is, since D is given as the number of additional fifths of a mile, there are 9 of those that he can go. So he can travel 9/5 in addition to the first 1/5 of a mile, which was covered by the original $3 fee. So 9/5 is the same as, so he can go 9/5 plus his original 1/5, which he paid for with the $3. This is 10/5 or 2 miles. So he can travel up to 2 miles with $7.50 in his pocket. So look at example or problem number 59 on the same page, 327. Hollis Sherman earned scores of 90 and 82 on his first 2 tests in English literature. What score must he make on his 3rd test to keep an average of 84 or higher? Now, let's just consider, let X equal the score needed on the 3rd test. That's an unknown. So this is an inequality. We know that to calculate an average, he has a 90 and an 82 plus the X that he needs, and the average is the sum divided by the number of individual parts that there are. And he wants to have a minimum of an 84 average. So what we're going to do here is we're going to multiply both sides by 3. As long as you multiply both sides by the same value. $84 times 3 is 252. 90 plus 82 is 172 plus X. It's greater than or equal to 252. Let's subtract the 172 from both sides. And what we're left with is X has to be greater than or equal to 80. So Hollis must get an 80 or better on the 3rd test in order for his average to be an 84. Let's look at one more problem here in this section. Number 62, a car rental. John and Suzanne Gainey went to California for a week. They needed to rent a car, so they checked out 2 rental firms. Agency A wanted $28 per day with no mileage fee, and Agency B wanted $108 per week and 14 cents per mile. How many miles would they have to drive before the Agency A price is less than the Agency B price? Well, this is number 62. So let's look at M being the number of miles. And cost, that's not a G, that's a C. Cost to rent each vehicle is from Agency A is 28 times 7. It's $28 a day times 7 days for a week, or 196. And agency B equal to 108 per week for the week, that is, plus 14 cents a mile, 14.14 times M. So to determine the number of miles at which the price to rent from agency B would exceed the price to rent from agency A, we have to look at an inequality. At what point is agency B going to be greater than agency A? So let's think about this. Uh, 196, or we could look at this as agency A is less than agency B. Same thing. So agency A is 196 less than 108 plus 0.14 M. Okay. So let's isolate these, subtract 108 from both sides. Get 88 is less than 0.14 M. Divide both sides by 0.14. And what we get is 628.6 is less than M. So they would have to drive more than 628.6 miles before the agency A price would be less than the agency B price. So again, you have to carefully read the problems and create your inequality and then solve the problem. That's all the concepts here for chapter 7, sections 7.4 and 7.5.